Hello everyone, my name is Samuel Oso and welcome back to my YouTube channel. So far we have seen so many concepts in Kubernetes. We have seen ports, we've seen deployment, we've seen services, we have seen HPA, we have even seen stateful sets, and we have seen config maps and secrets. So this video is extremely important, especially if you want to run Kubernetes properly in teams and in production, or in production rather. So now we are going to look at resource quota today, and I would love you to fully understand this topic. So it is not really about copying our resource file or copy my resource file. All right. So before we continue, please, if you are yet to subscribe to my channel, do well to subscribe to my channel, like this video, and you can also share this video with your friends. If at the end of this video and you still have troubles, you can drop your questions in the comment section and I will reply to them. So by the end of this video, we are going to fully understand how to set resource quotas for a namespace. We are going to see how to limit CPU. We are going to see how to limit memory, and we're also going to see how to limit other objects in our cluster. Now, why do we even need resource quotas? Now, imagine you have one cluster. Now, inside that cluster, you have different teams running different services. For instance, team A is running back-end services. Team B is running front-end services. Team C is running experiments. All right. Now, all of them are using the same cluster. What happens if one person accidentally deploys a pod that requests 20 CPU and 40 gig of RAM? Now, picture this scenario. That means this particular pod can do what? Can staff other workloads. This particular pod can staff other workloads. It can even block new pods from being scheduled, and it can affect the whole cluster. So this is what we call resource starvation. Now, understand that Kubernetes itself does not stop people from consuming too much. So we need a control layer. And that control layer is what is called resource quota. So resource quota is a very important idea. Now, resource quota works at the namespace level. Resource quota works at the namespace level. It does not work at the cluster level. It only works at the namespace level. So you do not put a quota on a deployment, you put a quota on a namespace. So a resource quota is simply a Kubernetes object that says, in this namespace, these are the maximum resources allowed. All right. So it can limit compute, CPU, memory. It can also limit object count. For instance, you can say, I need just 10 ports running in this namespace. I need just 2 services running in this namespace. So the big 2 categories are resource usage quotas and what? Object count quotas. Now, before we go into the practical session, there are two very important concepts, which are request and limit, because quotas depends on these two guys. What is a request? A request is what your container needs. All right. A request is what your container needs. All right. For instance, if your container needs 100 milli CPU to start, this is a request. I need at least this much resource to run. This is a request. How about limit? For a limit is what your container should not use more than. All right. If, let's say, your container requests 100 milli CPU to start, that means the scheduler will only place this spot on a node that has at least 100 milli CPU free space, or free CPU rather. But with limit, let's say you set the limit to 500 milli CPU. This means that it cannot go beyond the 500 milli CPU. The container can burst. So if it exceeds this CPU, it should throttle. If it exceeds this memory, it should go into what? OOM killed. So in summary, request is what I need. Limit is what I am allowed to use. So before we also go into the practical session too, let us also look at some units of measurement, because we are dealing with CPU and memory. Now, for CPU, one CPU is equals to 1000 milli CPU. So that means 500 milli CPU is half of one CPU. So 100 milli CPU is going to be 1/10 of a CPU. So these are basically binary units. Then for memory, you can have something like 128 MI. All right, 1 GI. So 1 GI is simply 1 gigabyte. 128 megabytes. All right. So let us take a look at a resource file for a resource quota. So note that resource quota do what? They work on the namespace level. All right. So that means we apply this to a particular namespace. So this is a resource quota for compute and also for objects. So this is the kind of object we are creating, resource quota. We are creating the development namespace, all right, or dev quota names, or yes, we are creating the dev namespace, all right. This is the name the resource quota is going to assume, all right. Now we have spec.hard. Spec.hard simply means that these are very strict limits. Now you can now define your limits here. So for ports, that means we cannot have more than 5 ports in this namespace. A port cannot request more than 2 CPU. That means the total number of ports running in this namespace should not request more than 2 CPU. A port cannot request more than 2 gigabytes of memory. The total number of ports, or the total number of memory request in this namespace is not more than 2. Now, pod cannot use more than 4 CPU. Pod cannot also use more than 4 gigabytes of memory. This namespace cannot have more than 2 services. It cannot have more than 5 config maps, and it cannot have more than what? 3 PVCs. So I'm going to create a namespace called dev before I can apply that to the dev namespace. So I'll do kubectl apply -f. Sorry. Kubectl create namespace or ns dev. All right. Then I can now apply the resource quota in the dev namespace. Kubectl apply -f. Yeah, dev quota. So our resource quota has been created. So if I do kubectl get resource quota -n dev. So this is the summary of our quota. All right. 0 out of 3 persistent volume claim, 0 out of 5 ports running, 0 out of 2 CPU requests. So let us go ahead and create a deployment. Let us go ahead and create a deployment. So first, we are going to create a pod. Or let us simulate with a pod first. So if I do, let us take a look at our pod YAML file. For a pod, we have declared the resource request and limit here. So that means this pod can request up to 500 milli CPU. So it fits in our pod in our request limit in the quota. It can request up to 512 megabytes, all right, and the limit it should go beyond when the pod is in the running state is what? 1, and it cannot use more than 1 gigabyte. So let us apply this. So kubectl apply -f. All right. So if you check, our pod has been created. So if I do kubectl, let us get our resource quota again. You see that we have 1 pod running. For the CPU request, 500 milli CPU out of 2. The same thing with the request memory. All right. Now let us simulate a failing pod or a resource. Let us just simulate a resource file that is going to cause or that is going to exceed our resource quota. So nano pod fail. So this is it. The request is 1 CPU, and the memory is what? 1. This exceeds our request and the CPU we stated in our request, and also the memory we quoted in our request. So I'm going to apply this. So kubectl apply. Let me confirm the namespace first. in the dev namespace. All right. So kubectl apply -f pod fill. So our pod fill has been created. So let us try to get pod. So let us try to get ports again. Kubectl get ports -n dev. Okay. A second, let us take a moment to cross-check something. So this guy is requesting what? The one CPU. All right, one CPU. So let us exit and let us get our quota first. All right, so okay. The request is, let us simulate nanopod fail. All right, so I am going to edit this CPU to 3. All right, then put this at 6. Let us just simulate what happens. So I'll save this and exit, then kubectl apply pod fill. So you can see that our pod is invalid because one, our CPU spec. But first, let us see this in action first so that we can see a very clear error. So let us delete our running pod first. Kubectl get ports -n dev. All right, so kubectl delete pod, the name is pod fill in the dev namespace. All right, so we are going to reapply our latest edit. So wait for this guy to finish terminating. Get ports. So let's wait for it to finish terminating. All right, so kubectl get ports. We have only this guy running. So let us try to apply our latest change. So we have an error because our limit exceeded quota. It is forbidden. Dev quota limit is 1 CPU. All right, so this is a very clear error message we have. So quota errors do not crash your cluster. Please note, quota error do not crash your cluster. What they simply do is that they block object creation. All right, so to fix this, we have two options. The first one is to reduce our workload. That is, we can reduce the request, or we adjust the quota itself. Then the pod creation will succeed. So without quotas, one namespace can consume everything. And of course, if you have other deployments and other teams in your cluster, then other teams will definitely suffer. So with quotas, you define guaranteed boundaries. Cluster becomes predictable. Platform teams can enforce fair usage. So this is one of the most important controls in production. So you can also try this out, create multiple services, and try to see how object creations are blocked. So when you define an object in your resource quota, you are simply preventing accidental infinite resource creation. So it is not only about CPU and memory, it is also about cluster hygiene. So resource quota works at the namespace level and it limits resource usage and object counts. All right. So we took we also saw the meaning of request and limit. So request is used to schedule quota accounting. Then limit is used for runtime enforcement. So if you truly understand this topic, then you are already thinking like a real Kubernetes platform engineer. All right. So do well not to quote or not to cram whatever is here. Do well to understand it properly. So it is not just about copying YAML files. So if you've stayed with me up till the end of this video, then I really appreciate you. Okay. So please, you can help me to like this video. You can also share this video with your friends. And if you have any questions, you can drop a comment on the video. Then I'm going to reply to it. So I'll see you in the next video.